was through graphing, right? And that's where they were in slope-intercept form, or you wanted them to be in slope-intercept form, and you look to see where the two lines crossed each other. Well, with substitution, we don't graph them, we plug in, because what does the word substitution mean? Do what? To replace something. Awesome. Good. Take a point. So what you're going to be looking for with substitution is you're going to look for one equation that has a variable by itself. So the first step says solve one equation for one variable. Choose an easy one. So usually I would pick the one that has 1 as a leading coefficient or that's already by itself. Then it says substitute the equation from 1 into another equation. Solve for the remaining variable and then plug in to find the other variable. Alright, now, which equation do we have here in our problem by itself already? The second one. Good. And we know what y equals, right? It says y equals 2x minus 1. So what we're going to do is we're going to replace y in the first equation with 2x minus 1. We're going to plug it in right there. Now, I'm going to use different colors to show you what it looks like visually. If you want to use one color, that's fine. But for me, different colors help on substitution especially. So our first equation is x plus 2. Now, what does y equal? 2x minus 1. And we set that equal to 8. Now, the way you know you've done it right when you're trying to find your first variable is if all of your variables are the same. We have all x's, we don't have any y's, so we know we plugged it in correctly. Now, how would we solve it from there? Great.
You would apply 2 to 2x and 2 to negative 1.
Good. Take a point. So we would distribute. 2 to 2x gives us 4x. 2 to negative 1 gives us minus 2. And then what do we do?
You combine my terms.
Good. And you get 5x minus 2 equals 8. And what is x? What do I do now? Add 2. Awesome. 5x equals 10. So what does x equal? 2. Now, are we done? What else do we have to find? We have to find y. Now, we know what x is. We know what y is equal to, so can we plug x in to find y? Yep. You're just going to take this green, and we're going to plug it in right here. So we're going to say y equals 2 times 2 minus 1. So what does y equal? 3. Awesome. And then we have to write it as a coordinate. Now, why do we write it as an ordered pair or a coordinate?
So you can graph it?
Kind of. Look back at your notes where we wrote down on page 41 about what a system is. And we wrote what a solution to a system is. What is a solution to a system of equations? And it's an ordered pair, right? It's a point. So you write it as an ordered pair because that's our solution. Our solution isn't just one of them, it's both. So you write it as 2, 3. Magic. And that's substitution. Anybody have any questions? You ready to practice some more? Oh, let me grab my notes that I should have brought up here like a normal human. Don't forget, it's a 3-day weekend, so please don't try to come to school Monday. Just to let you know. In case any of you forgot. Alright, so we're going to work our problems out on the back. We're going to call it 43B. As in potato. And the directions for our example will say solve each system. Now, I'm not going to tell you how I want you to solve it, because the point of this is to be able to look at your system and figure out what method to use. Example 1. Solve each system of equations. Our first problem that we're going to do in a system is how many equations?
2 or more.
At least 2 or more. Good. So you have y equals x plus 5 and 3x plus y equals 25. Alright, so what's the first thing we do when we're solving a system? Using substitution, which is what we're on. Look for the variable that's by itself, or see if they're both in slope-intercept form. Are they both in slope-intercept form? No, so we're not going to graph. Do we have a variable by itself? Alright, which variable is by itself? Y is. So what does y equal? You know, people besides Grant and Jackson can answer me. You guys know that, right? And Marbly. Like, we can talk to me. It's okay. So y is x plus 5. So what are we going to replace y with down here? X plus 5. Great job, Whitney. Alright, so we're going to come over here, and we're going to write 3x plus, are we going to write y, or are we going to write what y equals? What y equals. Awesome. What do I do from here? Combine like terms. Awesome. Take a point. 4x plus 5 equals 25. Whoever has Slytherin's point strip gets a point. And then you subtract 5. Take a point. And finally, divide by 4, and what does x equal? 5. Are we done? What do we do with this information?
Plug it into the other.
Plug it into the other equation. Now, do you think it really matters which equation we plug it into? No, because it's a solution to both. But since this y is already by itself, it's going to be easier to plug it into the top. So let's take it and plug it in right here. So we know that y equals, what's x? 5 plus 5. Alright, what's 5 plus 5?
10.
And how do we write our final answer? 5, 10. Good. Sean, take a point. Good job. Questions? Comments? Gripes? Complaints? You want to try one by yourself? What if I mix it up and... I'm not going to tell you. I'm just going to do it. You can handle it. Does Jayla have the flu?
Mm-hmm.
Okay. Does Caroline have the flu? We might talk to Caroline. Don't come to school if you have the flu, children. I do not have the flu. That's why I'm here. It's just congestion. That's what I got. Did everybody get 0 too? Did you say no?
Yes.
Well, what happened, Tater? Okay, well wait, don't erase. Look at your work compared to mine. Or just keep erasing. That's fine. Just keep going. What did you do?
Oh, everything's wrong.
Well, like, what did you do differently than me, Tater?
I mean, the first part was right, but yeah. No.
Okay. Do you know how to correct your mistake?
Yeah.
Are you sure?
I just copied.
Oh, okay. That's great. I'll just copy down. No worries. Alright, did anybody get hung up on the fact that it said X this time and you had to plug in for X instead of Y? Okay. Good. Well, we'll give Marbley a minute and then we'll do our next problem. No judgment, babe.
Okay, you're good.
Okay. I can't.
Can I get yelled
No.
I just start yelling back.
at?
It's boring, so like there's so.
Alright. This one.
Oh, okay. That negative one would be weird.
Did he make it right? Hey, good job. Take a point.
Yeah, that's what I thought I heard.
Good job, guys. I told you to watch out for this negative out front.
I started been working on that.
Yeah.
I don't know if I get this.
Okay. I'll give y'all a minute.
I got it right, but then you said it's not a trick question, but there was an actual answer.
No, I could see people getting to this point and they were like, I don't understand what I did. There were a lot of confused looking faces out there. So this negative, when you distribute it, you get negative y plus 1 plus y equals negative 1, and then negative y plus y cancels, and 1 does not equal negative 1 at all. Alright, uno más. We're going to do 2 more problems, and then homework, so dos más. Maybe Trace. We'll see. Alright, for this one, y equals negative 3x plus 4 and negative 6x minus 2y equals negative 8. Watch your signs, taters. Watch your signs on this one. Alright, so I didn't work this one out, sorry. It's not a big reveal this time. I was dancing. Right? And then you distribute. So you get negative 6x plus 6x minus 8 equals negative 8. Right? Negative 6x plus 6x cancels. You get negative 8 equals negative 8, which is infinite solutions. How many of us got that one right? Hey, take a point for your team. Good job. Alright, so now I want to do one where there's not necessarily a variable by itself, and I want you to tell me what we need to do so that we can still use substitution and not have to graph. So what if it looks like alright. So 3x plus 4y equals -3, and x plus 2y equals -1. We don't have a variable by itself, right?
So you just subtract 3, you subtract 2y.
Why would you do that?
Take the x by itself.
Why would you solve for this x instead of one up here?
Because the x are the number attached to it. So
Yes, awesome, great, take a point. Now, this x already has a leading coefficient of 1, so we would just solve for it to get it by itself. So you would subtract 2y from both sides. Can we combine that -2y and -1? No, because they're not like terms. And we get x equals -2y minus 1. So now that we know what x is, what can we do with it? Substitute. So we're going to take it, and we're going to plug it in right here. Can you guys work it out the rest of the way without me? Awesome. Did everybody get that one right? Okay, good. Take a point. Were you all nervous that time? Alright, are you ready to practice your homework? I want you to actually work out the word problems this time without me. So there are 8 total problems, 2 word problems, okay?